The machine that might destroy the world. 100 meters beneath the Swiss countryside. A tunnel 27 kilometers long. Temperatures colder than outer space. Particles racing at 99.9999% of the speed of light. 40 million collisions every second. Beautiful, yes, but that is just the science. Behind the equations are fears older than physics itself. Black holes that could swallow the Earth. Portals to other dimensions. A statue of Shiva the Destroyer standing guard over the most powerful experiment in human history. Lawsuits filed to stop it. Death threats sent to scientists. A teenage girl in India who ended her life the day it was switched on. And then there is the stranger theory that in 2012, when they found the God particle, something went wrong, that we were shifted into a parallel universe, that the Mandela effect, those shared false memories millions of people experience, is proof that reality itself has been altered. Is CERN opening a gateway to hell? Are we living in the wrong timeline? Or is this the greatest scientific achievement of our age, twisted by fear into something unrecognizable? The answers lie beneath the mountains, and they are more disturbing than you might expect. Chapter 1. The Machine Beneath the Mountains. But before we begin, do not forget to subscribe. And if you truly enjoy these videos, please leave a like. Let us begin. September 10th, 2008. The Swiss countryside looks peaceful from above. Green valleys, snow-capped peaks, villages that have stood for centuries. But 100 meters beneath this postcard surface, something is about to happen that will terrify millions of people around the world. In a tunnel stretching 27 kilometers in a circle, beneath the border of Switzerland and France, scientists are about to flip a switch. The largest machine ever built by humanity is about to wake up. The Large Hadron Collider, a ring of superconducting magnets cooled to temperatures colder than outer space, a cathedral of science buried in the darkness of the Earth, and according to some, a device capable of ending all life on this planet. Before the switch was flipped, lawsuits were filed in American courts. Physicists received death threats. A 16-year-old girl in India took her own life, convinced that the world was about to be swallowed by a black hole. The fears were real, even if the science behind them was not. This is the story of CERN, the European Organization for Nuclear Research, the most powerful scientific laboratory on Earth, a place where physicists smash particles together at nearly the speed of light to understand how the universe was born. But it is also the story of something else, the fears that technology beyond our understanding creates, the conspiracies that bloom in the gap between what science does and what the public perceives, the question that haunts every generation that builds something new. Are we playing with forces we cannot control? The story begins not in a tunnel, but in the rubble of a continent. 1954. Europe is still healing from the wounds of the Second World War. Cities lie in ruins. Nations that spent years destroying each other are struggling to find common ground. And in this landscape of reconstruction, a radical idea takes shape. What if the scientists who had fled Europe during the war could be brought back? What if the nations that had been enemies could unite around something other than weapons? What if physics, the discipline that had given the world the atomic bomb, could become a force for peace instead of destruction? The proposal came from an American physicist named Isidore Isaac Rabi at a UNESCO conference in 1950. He suggested that European countries pool their resources to build a research laboratory dedicated to fundamental physics, not weapons research, not military applications, pure science, understanding the universe for the sake of understanding it. By 1952, a provisional council had been formed. The French name was Conseil européen pour la recherche nucléaire, the European Council for Nuclear Research. The acronym was CERN. Even when the formal organization replaced the council 2 years later, the name stuck. It still does today. On September 29, 1954, 12 European nations ratified the CERN Convention. The organization came into being with a mission written directly into its founding documents. Article 2 states clearly that CERN shall have no concern with work for military requirements. The results of its research shall be published or otherwise made generally available. This was not going to be another Manhattan Project. This would be open science, shared knowledge, a rejection of the secrecy that had defined atomic research during the war. The site chosen was Geneva, neutral Switzerland, a country that had stayed out of the conflict, a city positioned almost exactly at the geographic center of Western Europe. Ground was broken in 1955. The first Director General, Felix Bloch, laid the foundation stone while the President of the Swiss Confederation watched. A laboratory was rising from the Earth. The first accelerator came online in 1957, the synchrocyon, a machine that could accelerate protons to 600 million electron volts. It seems almost quaint now, but at the time it represented the cutting edge of human capability. More machines followed, bigger, more powerful, each generation building on the discoveries of the one before. In 1959, the proton synchrocyon began operation. It would become the heart of CERN's accelerator complex, a role it still plays today. By the 1970s, CERN had built the intersecting storage rings, the world's first hadron collider. For the first time, physicists could smash particles together head-on rather than firing them at stationary targets. The energy released in these collisions opened windows into the subatomic world that had never been accessible before. The discoveries mounted. In 1973, CERN physicists found evidence of neutral currents, particles that confirmed a theoretical prediction about how forces operate at the quantum level. In 1983, Carlo Robbia and Simon von der Meer discovered the W and Z bosons, earning them the Nobel Prize the following year. These were not abstract curiosities. They were the carriers of the weak nuclear force, one of the four fundamental forces that govern everything in the universe. But CERN's ambitions were growing faster than its machines could satisfy. Physicists wanted to probe deeper. They wanted to understand why particles have mass. They wanted to find the last missing piece of the standard model of particle physics, a theoretical framework that describes all known fundamental particles and how they interact. That missing piece had a name, the Higgs boson, and finding it would require a machine unlike anything the world had ever seen. In 1989, CERN completed the Large Electron Positron Collider, LEP. It occupied a new tunnel 27 kilometers in circumference, buried deep beneath the French and Swiss countryside. For 11 years, LEP smashed electrons and their antimatter counterparts, positrons, together at energies approaching 100 billion electron volts. The machine made precise measurements of particles, refined theoretical predictions, and pushed the boundaries of what was known. But LEP was always meant to be a stepping stone. The tunnel had been designed with its successor in mind. When LEP shut down in November of 2000, the real project began. Engineers started modifying the tunnel, excavating new caverns for massive detectors, preparing for something that would take another 8 years to complete. The Large Hadron Collider, LHC. Staggering. 27 kilometers of tunnel, over 9,000 magnets, 90 tons of liquid helium cooling the entire system to 1.9 degrees above absolute zero, colder than the vacuum of outer space. 2 beams of protons racing in opposite directions at 99.999% of the speed of light. 40 million particle collisions every second, 600 million collisions every second when running at full capacity. Over 10,000 scientists and engineers from more than 100 countries contributed to the design and construction. The cost exceeded $10 billion. The detectors alone, the instruments that record what happens when particles collide, weigh tens of thousands of tons. Atlas, one of the main detectors, stands 7 stories tall and weighs more than the Eiffel Tower. CMS, another detector, contains more iron than the Eiffel Tower as well. These are not instruments in any ordinary sense. They are monuments to human ambition, temples of measurement buried in the darkness of the earth. Construction began in earnest after 2000. Caverns were hollowed out of the rock. Magnets were manufactured in factories across Europe and shipped to Geneva. Cables were laid, computers hummed. The machine took shape, piece by piece, year by year, a puzzle of unprecedented complexity being assembled by hands from every corner of the globe. By 2008, the LHC was ready for its first test. September 10th was chosen as the day to circulate the first beam. The world watched. Cameras were positioned in the control room. Journalists filed stories about the dawn of a new era in physics. Scientists who had dedicated their entire careers to this moment held their breath. And somewhere in the background, fear was growing. The fears were not entirely irrational, at least not in their origins. When you build a machine capable of recreating conditions that existed a fraction of a second after the Big Bang, people are going to ask questions. What happens if something goes wrong? What happens if the energies released create something unexpected? What happens if we tear a hole in the fabric of space and time? The specific fears centered on 2 possibilities.
The first was black holes. The LHC would smash protons together at energies never before achieved on Earth. Some physicists speculated that these collisions might, in theory, produce microscopic black holes, tiny points of infinite density that would immediately begin consuming everything around them, starting with a detector, then the tunnel, then Switzerland, then Europe, then the planet. The second fear was strangelets. Strange matter is a hypothetical form of matter made up of equal parts of up, down, and strange quarks, rather than the ordinary combination found in protons and neutrons. If a strangelet, a tiny piece of strange matter, came into contact with ordinary matter, it might convert that matter into more strange matter, a chain reaction that would transform the entire Earth into a small ball of exotic particles roughly 100 meters across. These scenarios sound like science fiction. They are, but they are science fiction rooted in actual physics. The equations that describe particle collisions do not entirely rule out these possibilities. The probabilities are infinitesimally small, but they are not zero. And in a world where complex science is often reduced to headlines, the nuance was lost. Black holes at CERN, Earth swallowed by particle experiments, the end of the world beneath Geneva. Lawsuits were filed. Walter Wagner, who had previously tried to stop the relativistic heavy ion collider at Brookhaven National Laboratory in New York, filed suit in federal court in Hawaii in 2008. Luis Sancho joined him as a plaintiff. They demanded that CERN produce a proper environmental impact statement before the LHC could operate. They claimed that the risks had been downplayed, that the safety assessments were incomplete, that scientists were gambling with the fate of humanity. The suit was dismissed. So were similar cases in Germany and at the European Court of Human Rights. CERN had commissioned multiple independent safety studies. The conclusions were unanimous. There was no conceivable risk. Cosmic rays, high-energy particles from space, strike the Earth, the Moon, and every other body in the universe constantly. These cosmic ray collisions occur at energies far higher than anything the LHC could produce. If microscopic black holes or strangelets could be created in particle collisions, they would have been created naturally countless times over billions of years. The Moon would have been converted to strange matter long ago. The Earth would have been swallowed by black holes before humanity ever existed. The universe itself has been conducting these experiments since the beginning of time. We are still here, but fear does not respond to logic. On September 10, 2008, as the first protons circled the LHC for the first time, there were people around the world convinced that these would be their last moments. Some prayed, some hid, some made peace with their loved ones. In India, a teenage girl named Chia, believing the reports she had seen on television about the world ending, ended her own life. The beam circulated successfully. Nothing catastrophic happened. The scientists celebrated. The champagne was opened. A new era had begun. 9 days later, on September 19th, a fault in one of the electrical connections caused a catastrophic failure. A magnet quenched, releasing its stored energy explosively. Helium escaped into the tunnel. 53 magnets were damaged. The LHC would not operate again for over a year while repairs were made. The conspiracy theorists had an explanation for that, too. Time travelers from the future, they said, had sabotaged the machine. They were trying to prevent a disaster that had already happened in their timeline. The LHC was so dangerous that the universe itself was conspiring to stop it. This was only the beginning. The real storm of conspiracy theories was still to come. It would arrive 4 years later, on a date that believers still cite as the moment everything changed. July 4th, 2012. Independence Day in the United States. A Wednesday, scientists at CERN gathered in a packed auditorium in Geneva at 9 in the morning local time. Across the Atlantic, their American colleagues were waking up in the middle of the night, on a holiday no less, to watch the live stream. Physicists and laboratories around the world interrupted their work, gathering around screens. Something historic was about to be announced. Fabiola Giannatoli, the spokesperson for the Atlas experiment, took the stage first. She presented slides filled with graphs and statistical analysis. Her voice was steady, but barely contained. Excitement broke through. Then Joe Incandela, spokesperson for the CMS experiment, presented the data from his detector. The graphs told the same story. The statistical threshold had been crossed. 5 sigma, the gold standard in particle physics. A 1 in 3.5 million chance that the results were a random fluctuation. They had found it. The Higgs boson. The audience erupted in applause. Peter Higgs, the 83-year-old British physicist who had first proposed the particle's existence nearly half a century earlier, sat in the front row with tears in his eyes. The hunt that had consumed careers, driven the construction of the LHC, that the safety assessments were incomplete, that scientists were gambling with the fate of humanity. The suit was dismissed. So were similar cases in Germany and at the European Court of Human Rights. CERN had commissioned multiple independent safety studies. The conclusions were unanimous. There was no conceivable risk. Cosmic rays, high-energy particles from space, strike the Earth, the Moon, and every other body in the universe constantly. These cosmic ray collisions occur at energies far higher than anything the LHC could produce. If microscopic black holes or strangelets could be created in particle collisions, they would have been created naturally countless times over billions of years. The Moon would have been converted to strange matter long ago. The Earth would have been swallowed by black holes before humanity ever existed. The universe itself has been conducting these experiments since the beginning of time. We are still here. But fear does not respond to logic. On September 10, 2008, as the first protons circled the LHC for the first time, there were people around the world convinced that these would be their last moments. Some prayed, some hid, some made peace with their loved ones. In India, a teenage girl named Chia, believing the reports she had seen on television about the world ending, ended her own life. The beam circulated successfully. Nothing catastrophic happened. The scientists celebrated. The champagne was opened. A new era had begun. 9 days later, on September 19th, a fault in one of the electrical connections caused a catastrophic failure. A magnet quenched, releasing its stored energy explosively. Helium escaped into the tunnel. 53 magnets were damaged. The LHC would not operate again for over a year while repairs were made. The conspiracy theorists had an explanation for that too. Time travelers from the future, they said, had sabotaged the machine. They were trying to prevent a disaster that had already happened in their timeline. The LHC was so dangerous that the universe itself was conspiring to stop it. This was only the beginning. The real storm of conspiracy theories was still to come. It would arrive 4 years later, on a date that believers still cite as the moment everything changed. July 4th, 2012. The day CERN announced the discovery of the God particle. The day, according to some, that humanity was shifted into a parallel universe from which we can never return. But that is a story for the next chapter. Chapter 2. The God particle and the day everything changed. July 4th, 2012. Independence Day in the United States. A Wednesday. Scientists at CERN gathered in a packed auditorium in Geneva at 9 in the morning local time. Across the Atlantic, their American colleagues were waking up in the middle of the night, on a holiday no less, to watch the live stream. Physicists in laboratories around the world interrupted their work, gathering around screens. Something historic was about to be announced. Fabiola Gianotti, the spokesperson for the Atlas experiment, took the stage first. She presented slides filled with graphs and statistical analysis. Her voice was steady, but barely contained. Excitement broke through. Then, Joe Incandela, spokesperson for the CMS experiment, presented the data from his detector. The graphs told the same story. The statistical threshold had been crossed. 5 sigma, the gold standard in particle physics. A 1 in 3.5 million chance that the results were a random fluctuation. They had found it. The Higgs boson. The audience erupted in applause. Peter Higgs, the 83-year-old British physicist who had first proposed the particle's existence nearly half a century earlier, sat in the front row with tears in his eyes. The hunt that had consumed careers, driven the construction of the—
Call it the goddamn particle, a reference to how frustratingly difficult it was to find. His publisher changed it to something more marketable, the God particle. The name was meant to be playful. It had nothing to do with religion or spirituality, but names have power. And in a world where science is often misunderstood, where complex concepts are reduced to headlines, the name became a lightning rod. CERN had discovered the God particle. CERN was playing with the fundamental building blocks of reality. CERN was tampering with forces that perhaps humans were not meant to touch. The conspiracy theories that had simmered since 2008 suddenly boiled over, and they took forms that no one at CERN had expected. The most widespread theory connected the Higgs discovery to a psychological phenomenon that had been gaining attention on the internet, the Mandela effect. Named after South African leader Nelson Mandela, the phenomenon describes the experience of many people sharing the same false memory. Large numbers of people remember Mandela dying in prison in the 1980s. He did not. He was released in 1990, became president of South Africa, and died in his home in 2013. How could so many people share the same incorrect memory? The believers had an answer: CERN. According to this theory, the experiments at the Large Hadron Collider, particularly the discovery of the Higgs boson in 2012, had done something to reality itself. The collision energies had torn a hole in the fabric of space-time. We had been shifted into a parallel universe, an alternate timeline. The memories people had were real memories, but they were memories from the original timeline, the one we left behind when CERN's experiments transported us here. This explained everything. Why did the children's book series spelled Berenstain Bears now, when so many people remembered it as Berenstein Bears? Timeline shift. Why did people remember the Monopoly Man wearing a monocle when he never had? Timeline shift. Why did people remember the movie Shazam starring the comedian Sinbad when that movie never existed? Timeline shift. The theory spread rapidly on social media. Reddit threads accumulated thousands of comments. YouTube videos racked up millions of views. A community formed around the belief that CERN had fundamentally altered reality and that the differences people noticed were not failures of memory, but evidence of the shift. The International Mandela Effect Conference was held in 2019 and again in 2020. Researchers like Cynthia Sue Larson, author of books on reality shifts and quantum jumps, became prominent voices. They watched CERN's experiments carefully, convinced that each new activation of the LHC would produce fresh Mandela effects, new discrepancies between collective memory and recorded fact. CERN noticed. They had to. The theories were too widespread to ignore. Clara Nellis, a particle physicist working on the ATLAS experiment, took to TikTok to address the conspiracy theories directly. She explained that the LHC simply recreates collisions that happen naturally in Earth's atmosphere all the time. Cosmic rays, particles from space, strike our atmosphere at energies far higher than anything the LHC produces. If these collisions could tear holes in space-time or shift us between dimensions, it would have happened long ago. The Mandela effect, she suggested, has a much simpler explanation. Human memory is fallible. We misremember things constantly. When an unusual spelling like Berenstain feels wrong, our brains naturally correct it to the more familiar Brennenstein. When we half remember a movie we saw as children, our brains fill in the gaps with plausible details. When millions of people all have similar brains making similar errors, you get shared false memories. But the believers were not convinced. After all, they could point to something that seemed deeply suspicious. CERN's experiments had become more powerful since 2012. New runs of the LHC at higher and higher energies, and strangely, the world seemed to be getting stranger. Politics had become more chaotic. Events seemed more improbable. Reality itself felt off. In 2016, a Twitter user named Nick Hinton proposed a theory that would go viral. CERN had destroyed the world in 2012, he claimed during the Higgs boson experiments. We were all now living in a simulation or in a branch of the multiverse that had split off from the main timeline. This explained why everything since 2012 had felt so wrong. We were no longer in our original reality. Stephen Hawking had written about the Higgs boson in the preface to a book called Star Mass. He mentioned that the Higgs potential, a mathematical concept related to the Higgs field, could theoretically become unstable at very high energies. This could cause what Hawking called catastrophic vacuum decay, a process in which the universe would transition to a more stable state, destroying everything in the process. Conspiracy theorists seized on this. Hawking had warned us, they said. CERN's experiments could destroy the universe, and maybe they already had. Maybe we were now living in the aftermath, in whatever strange shadow reality emerged from the ruins. The scientists at CERN were patient. They explained again and again that Hawking had been discussing a theoretical possibility at energies far beyond anything the LHC could achieve. The LHC operates at energies around 14 trillion electron volts. The energy scales Hawking discussed were billions of times higher. The universe is not in danger from CERN's experiments, but fear, once planted, is difficult to uproot.
The Higgs discovery had given the conspiracy theorists something concrete to point to. CERN had found the God particle. They were manipulating the fundamental fabric of reality. How could anyone be certain that nothing had gone wrong? The answer, according to the physicists, was the universe itself. Cosmic rays have been bombarding the Earth and every other body in the universe for billions of years. The moon, white dwarf stars, neutron stars, all are constantly struck by particles at energies far higher than the LHC produces. If these collisions could create dangerous black holes or trigger vacuum decay, these celestial bodies would have been destroyed long ago. They still exist. The universe still exists. We are still here. But to the believers, this logic missed the point. Something had changed. They could feel it. The world was different now. Reality was different now. And CERN was the obvious culprit. The discovery of the Higgs boson was a triumph of human ingenuity. 50 years of theory, decades of engineering, billions of dollars, and the collaborative effort of thousands of the brightest minds on the planet had come together to answer one of the deepest questions about the nature of reality. Why does anything have mass at all? But that same discovery had become a foundation for fear. The God particle, the machine beneath the mountains, the scientists who dared to recreate the conditions of the Big Bang. And as we will see in the next chapter, the conspiracy theories were only beginning. Portals to hell, shadow people from other dimensions, satanic rituals, the statue of Shiva the Destroyer standing watch over the collider. CERN had opened Pandora's box. The question was whether they could ever close it again. Chapter 3. Portals, Black Holes, and the End of the World. Walk onto the CERN campus and you will see something unexpected. Standing in a courtyard between buildings filled with servers and laboratories is a bronze statue 2 meters tall. It depicts a figure with 4 arms, 1 leg raised, dancing within a ring of flames. This is Nataraja, the Lord of Dance, a depiction of the Hindu deity Shiva in his cosmic role as the destroyer and transformer of the universe. The statue was a gift from the Indian government in 2004, celebrating the long partnership between India and CERN that had begun in the 1960s. For physicists, it represents a beautiful metaphor. Shiva's dance symbolizes the cosmic cycles of creation and destruction, the rhythm of existence, the endless transformation of matter in energy. What better symbol for a laboratory dedicated to understanding the fundamental processes of the universe? For conspiracy theorists, the statue means something else entirely. Shiva is the destroyer. CERN has placed a giant statue of the destroyer at the entrance to the most powerful particle collider on Earth. This cannot be a coincidence. This must be a message, a warning, or perhaps a confession. The theory that CERN is attempting to open a portal to another dimension, possibly hell itself, has become one of the most persistent and elaborate conspiracy narratives of the internet age. It draws on religious symbolism, misunderstood physics, Hollywood science fiction, and a deep distrust of elite institutions operating beyond public oversight. The pieces of the puzzle, as believers see them, fit together too neatly to be accident. The Shiva statue, the location of CERN on the border between 2 countries, a liminal space. The name of the nearby town, Saint-Genès-Puy, which some have claimed derives from Apollon, the angel of the abyss mentioned in the Book of Revelation. The circular shape of the LHC, a ring which in esoteric traditions represents portals or gateways. Even the numbers, the circumference of the collider is 16.6 meters, close enough to 666 for the numerologically inclined. None of these connections hold up to scrutiny. Saint-Genès-Puy is named after Saint Genesius, a Roman actor martyred for his Christian faith, not Apollon. The circumference of the LHC is actually 26.7 kilometers, which converts to roughly 16.6 meters only through creative rounding. The Shiva statue is publicly displayed art with a clear and documented history. But conspiracy theories do not need facts. They need patterns, and for those looking for patterns, CERN offers plenty. The portal theory gained significant momentum in July of 2016, when unusual cloud formations were photographed over the Geneva area. The images showed a dramatic supercell, a rotating thunderstorm with a distinctive structure. The photographs were taken by Swiss nature photographer Christophe Suarez on June 24th of that year. He posted them to social media, noting the unusual weather patterns he had captured. Within days, the images had been repurposed. A YouTube channel called Freedom Fighter Times reposted the photographs on June 27th with a very different narrative. These were not clouds, the channel claimed. This was a ball of energy in the sky above CERN, evidence that the Large Hadron Collider had opened a portal. The video accumulated hundreds of thousands of views. Suarez objected. He pointed out that his photographs had been taken and reposted without his permission. More importantly, they had not been taken over CERN at all. They showed weather phenomena that Swiss meteorologists had predicted. Normal atmospheric conditions captured by a skilled photographer, transformed by the internet into evidence of interdimensional breach. But the story had already escaped. Other videos followed, other supposed evidence of portals, strange lights in the sky, unexplained phenomena. Each piece was folded into the growing narrative. CERN was opening doorways to other dimensions, perhaps to hell itself. The religious dimension of the conspiracy is significant. For some believers, CERN represents humanity's attempt to challenge God. The search for the God particle is seen not as scientific inquiry, but as hubris. Building a machine to recreate the conditions of creation is seen as an act of defiance, an attempt to know what humans are not meant to know. The Book of Genesis warns against eating from the tree of knowledge. CERN is eating. From this perspective, the scientists at CERN are not simply misguided, they are engaged in a spiritual battle. Whether consciously or not, they are serving forces opposed to the divine order. The portal they are opening is not metaphorical, it is literal, and what might come through it is not particles, but entities. This interpretation found dramatic expression in August of 2016 when a video surfaced online that appeared to show a ritual sacrifice taking place on the CERN campus. The footage, shot at night, depicted several figures dressed in black robes gathering around the Shiva statue. A woman, dressed in white, lay on the ground. One of the robed figures appeared to stab her. The person filming cried out and fled. The video went viral. Conspiracy websites proclaimed it as proof of satanic rituals at the heart of the world's most advanced physics laboratory. The mainstream media picked up the story. CERN was forced to respond. A spokesperson confirmed that the video was real in the sense that it had actually been filmed on CERN property, but it was a prank, a hoax staged by people with access badges who had decided to mock the conspiracy theories surrounding the organization. No one was actually harmed. The sacrifice was fake. CERN launched an internal investigation. The organization stated that such spoofs were not condoned and could give rise to misunderstandings about the scientific nature of their work. But the damage was done. The video remained online. The images of robed figures surrounding the destroyer spread across the internet. For conspiracy theorists, the official explanation was itself suspicious. Of course, CERN would claim it was a prank. What else would they say? The fact that no names were released, that no one was identified or punished, only deepened the suspicion. Perhaps it was not a prank at all. Perhaps it was a ritual disguised as a prank. Or perhaps it was a genuine ritual that CERN was forced to dismiss as performance when it was unexpectedly filmed and exposed. The portal theories connect to older fears about CERN and black holes. From the beginning, before the LHC ever operated, there were concerns that the collider might create microscopic black holes. CERN's response was always scientific. Yes, some theories suggest that high-energy collisions might produce tiny black holes, but these would be incredibly small, far smaller than an atom, and they would evaporate instantly through a process called Hawking radiation. Stephen Hawking predicted in the 1970s that black holes are not entirely black. Quantum effects at their boundaries cause them to slowly emit particles and lose mass. For a black hole the size of a proton, this evaporation would be nearly instantaneous. The black hole would wink into existence and disappear before it could interact with anything. Critics of CERN pointed out that Hawking radiation had never been directly observed. It remained theoretical. What if Hawking was wrong? What if the tiny black holes did not evaporate? What if they persisted, growing larger as they consumed matter around them, eventually swallowing the Earth? CERN commissioned independent safety studies. Physicists examined the arguments carefully. Their conclusion was reassuring. Even if Hawking radiation did not work as expected, cosmic ray observations proved the safety of the LHC. Cosmic rays are high-energy particles that strike the Earth and other bodies constantly. The energies involved in some cosmic ray collisions far exceed anything the LHC could produce. If stable microscopic black holes could be created in particle collisions, they would have been created naturally over billions of years. The Earth has been bombarded by cosmic rays for 4.5 billion years. The Moon has been bombarded for just as long. Neutron stars and white dwarfs, which are far denser than Earth, have been bombarded as well. If dangerous black holes could form from particle collisions, these bodies would have been consumed long ago. They still exist. We still exist. The argument from cosmic rays is essentially airtight. But conspiracy theories are not built on scientific arguments. They're built on distrust. And the distrust of CERN runs deep. Some of the distrust is rooted in legitimate concerns about the complexity and opacity of modern science. The physics of the LHC is genuinely difficult to understand. The mathematics is beyond the reach of non-specialists. The language is technical, the experiments are conducted underground, out of sight, by elite institutions operating with billions of dollars in funding. Even scientists who support CERN acknowledge that the public understanding of what happens there is limited. In this knowledge gap, fear grows. When people cannot understand what is being done in their name, they imagine the worst. When they see a giant statue of a destroyer, when they see photographs of strange clouds, when they see videos of robed figures, the imagination fills in the blanks. The fear of black holes, of portals, of rituals, of entities from other dimensions is ultimately a fear of the unknown. It is the ancient fear that we are tampering with forces beyond our control. It is the fear of Prometheus, who stole fire from the gods and was punished for eternity. It is the fear of Icarus, who flew too close to the sun. It is the fear that there are some things humanity is not meant to know. CERN scientists reject this fear. They believe that knowledge is always worth pursuing. They believe that understanding the universe makes humanity stronger, not weaker. They believe that the fears surrounding their work are based on misunderstanding and can be addressed through education and transparency. But as we will see in the next chapter, the fears are not going away. The Mandela Effect community continues to watch every activation of the LHC. The portal theorists continue to interpret every unusual phenomenon as evidence of dimensional breach, and new theories continue to emerge, each more elaborate than the last. The machine beneath the mountains runs on. The collisions continue. The data accumulates. And in the space between what science knows and what the public fears, the conspiracy theories thrive. Chapter 4. The Mandela Effect and Reality Unraveled. Do you remember the Berenstain Bears? The beloved children's book series about a family of bears living in a treehouse, learning lessons about honesty and sharing and the importance of eating your vegetables. Think carefully. Picture the books in your mind, the covers, the titles, the spelling of the name. Now go to a library or search online for an image. Look at the actual cover of any Berenstain Bears book published in the last 60 years. It is spelled Berenstain with an A, not Berenstein with an E. Berenstain and Jan Berenstain, the husband and wife team who created the series in 1962, named the bears after themselves. The spelling has never changed. Every book ever published has the same spelling, Berenstain. And yet, millions of people remember it differently. Polls consistently show that a majority of Americans believe the name was Berenstein. They can picture it. They can hear it. They know they read those books as children. They know what they saw. How is this possible? Welcome to the Mandela Effect. The term was coined in 2009 by Fiona Broome, a self-described paranormal researcher. Broome discovered that she was not alone in remembering Nelson Mandela dying in prison in the 1980s. She distinctly recalled his death, his funeral, even his widow giving a speech. The only problem was that Nelson Mandela was alive. He had been released from prison in 1990, become president of South Africa, and would live until 2013. Broome started a website to document this phenomenon. Others began sharing their own false memories. The Berenstain Bears. The Monopoly Man's monocle. There is no monocle. There never was. But many people can picture it clearly. The spelling of the Jiffy peanut butter brand. There is no Jiffy. The brand is Jif. The movie Shazam, starring the comedian Sinbad as a genie. The movie does not exist. It was never made, but thousands of people remember watching it. The examples accumulated. Film quotes were wrong. Luke, I am your father is not the line from The Empire Strikes Back. The actual line is no, I am your father. Life is like a box of chocolates is often attributed to Forrest Gump, but in the film, Tom Hanks says life was like a box of chocolates. Mirror, mirror on the wall appears nowhere in Disney's Snow White. The line is magic mirror on the wall. These discrepancies are individually trivial, misremembered quotes, Misspelled names confuse details, but collectively they form a pattern that many people find disturbing. Why do so many people share the same wrong memories? Why are the errors so consistent across populations? The scientific explanation is straightforward. Human memory is not a recording device. It does not capture events with perfect fidelity and play them back unchanged. Memory is reconstructive. Every time you recall something, you are rebuilding it from fragments, and in that process, errors creep in. Common errors are especially likely when the correct version is unusual or counterintuitive. Berenstain is an uncommon spelling. Berenstein feels more natural because names ending in Stein are far more common. The brain, seeking patterns, smooths the unusual into the expected. When millions of brains make the same smoothing error, you get a collective false memory. Psychologists have studied the Mandela effect experimentally. Research published in Psychological Science in 2022 confirmed that people consistently misremember certain details about famous logos and characters. When asked to draw these icons from memory, participants reliably reproduced the wrong versions. The errors were not random. They followed predictable patterns based on how our brains process and store visual information. The science is clear. The Mandela effect is a product of fallible human memory interacting with social confirmation. When you discover that others share your false memory, it feels validating. The memory seems more real because it is shared. But shared does not mean accurate. This explanation does not satisfy everyone. For a significant number of people, the Mandela effect is not a failure of memory. It is evidence of something far stranger.
Universes, timeline shifts, reality itself being altered. And the entity responsible for this alteration, according to the most popular version of the theory, is CERN. The logic goes like this. CERN operates the most powerful particle accelerator in the world. The experiments conducted there probe the fundamental structure of matter and energy. In 2008, the LHC was activated. In 2012, the Higgs boson was discovered. These experiments involve recreating conditions that existed moments after the Big Bang. They involve energies and processes that are genuinely difficult to comprehend. What if something went wrong? What if one of these experiments accidentally punched a hole in the fabric of space-time? What if we were shifted without knowing it from our original timeline into a parallel universe where small details are different? This would explain everything. The memories people have are not false. They are accurate memories from the original timeline. The Berenstain Bears really were spelled with an E in the universe we came from. Nelson Mandela really did die in prison. The Monopoly Man really did wear a monocle. We remember correctly. It is reality that is changed. The theory is unfalsifiable, which makes it both powerful and resistant to evidence. Any discrepancy can be attributed to the timeline shift. Any evidence against the theory, such as old Berenstain Bears books with the A spelling, can be explained as having been altered along with everything else. The theory creates its own closed loop of logic. CERN has the collisions produced are microscopic, affecting individual particles. They cannot alter reality on a macroscopic scale. The physics simply does not work that way. Furthermore, similar collisions happen naturally in our atmosphere constantly. Cosmic rays strike air molecules at energies far exceeding anything the LHC produces. These collisions have been occurring for billions of years without shifting anyone between timelines. If particle collisions could alter reality, the universe would be unstable. It is not. But the believers are not persuaded. They point to the timing. The Mandela effect seems to have intensified since 2012, the year of the Higgs discovery. They point to the strangeness of the world. Politics has become more chaotic. Events seem more improbable. Reality feels off. This is where the CERN conspiracy theories intersect with a broader cultural anxiety. The world in the 2010s and beyond has felt to many people increasingly unstable. Political polarization, economic uncertainty, pandemic, war. The sense that things are not right, that the timeline has gone wrong, is widespread. For some, the Mandela effect and its connection to CERN provides an explanation. The world feels strange because it is strange. We are not where we are supposed to be. Something fundamental has been altered. This is emotionally satisfying in a way that the scientific explanation is not. Memory errors are mundane. Timeline shifts are cosmic. Being a person with a flawed memory is humbling. Being a traveler from an alternate dimension is extraordinary. The Mandela effect community continues to grow. Subreddits accumulate new examples. YouTube channels document discrepancies.
Conferences bring believers together to share experiences. Every time the LHC operates at new energy levels, watchers track alleged new effects. In July of 2022, when the LHC began its third operational run at higher energies than ever before, the conspiracy theories spiked. TikTok accounts went viral, claiming that CERN was about to open portals to other dimensions. The hashtag gained millions of views. CERN scientists again took to social media to explain that nothing dangerous was happening. The cycle repeats. The machine runs, the theories spread, the anxieties persist.
Explanations are offered. The believers remain unconvinced. What is perhaps most interesting about the Mandela effect phenomenon is what it reveals about the relationship between science and public trust. CERN is one of the most open scientific institutions in the world. Its research is published freely. Its facilities are open to visitors. Its scientists actively engage with the public. Yet despite this transparency, conspiracy theories flourish. The gap is not primarily about information. It is about comprehension. The physics of the LHC is genuinely beyond the understanding of most people, including most educated people. The concepts are abstract. The mathematics is advanced. The experiments are invisible. When the public cannot understand what is being done, they fill the void with imagination. And imagination, especially fearful imagination, rarely flatters. We imagine the worst because the worst is what we are wired to fear. Evolution did not prepare us for particle physics. It prepared us for predators and enemies and things lurking in the dark. When we encounter something vast and incomprehensible, we reach for the stories we know: portals, demons, the end of the world. CERN cannot close the knowledge gap simply by offering more information. The challenge is deeper. It requires a different kind of engagement. It requires helping people understand not just what is being done, but why it matters and why it is safe. It requires meeting fear with patience rather than dismissal. The scientists at CERN are doing this work. They make videos, they give interviews, they explain. Some of them have become skilled communicators, translating complex physics into accessible language. But the work is never done. The theories regenerate. The fears persist. In the final chapter, we will step back and ask the larger questions. What does CERN actually do? What has it discovered? What are the real risks and benefits of its research? And what does the conspiracy phenomenon tell us about our relationship with science, knowledge, and the unknown? The answers may not satisfy everyone, but they are worth pursuing because understanding is always better than fear, even when fear is easier. Chapter 5: Science, Fear, and what CERN really does. Let us set aside the conspiracies for a moment. Let us talk about what CERN actually does. What happens when protons collide at nearly the speed of light? What have scientists learned? What are they hoping to learn? And why does any of it matter? The Large Hadron Collider accelerates two beams of protons in opposite directions around a 27-kilometer ring. Each beam contains billions of protons, traveling at 99.999991% of the speed of light. At 4 points around the ring, the beams cross and protons collide. The energy released in each collision is concentrated in a space smaller than an atomic nucleus. This energy converts to mass, according to Einstein's famous equation. New particles spring into existence. They live for the tiniest fractions of seconds before decaying into other particles. Detectors the size of buildings record everything. What emerges from this chaos is data. Billions of collisions generate petabytes of information. Scientists analyze this data, looking for patterns, for anomalies, for signatures of particles that theory predicts, but experiment has never confirmed. The most famous discovery, of course, is the Higgs boson, found in 2012 after decades of searching. But the Higgs is not the end. It is a beginning. The particle's properties are still being measured with increasing precision. Any deviation from theoretical predictions could point toward new physics, new particles, new forces that the standard model does not describe. Beyond the Higgs, scientists at CERN study matter and antimatter. Every particle has an antimatter counterpart with opposite charge. When matter and antimatter meet, they annihilate each other, converting their mass to energy. The Big Bang should have created equal amounts of matter and antimatter. They should have annihilated completely, leaving nothing but light. Yet, here we are. The universe is made of matter. Where did all the antimatter go? This is one of the deepest mysteries in physics, and CERN experiments are probing it. Scientists study dark matter, the invisible substance that makes up most of the mass in galaxies. We know dark matter exists because of its gravitational effects. Stars orbit galactic centers too fast to be held by visible matter alone. Something else is there, something that does not interact with light. The LHC might produce dark matter particles, revealing what this mysterious substance actually is. They study quarks and gluons, the fundamental building blocks of protons and neutrons. When the LHC collides heavy ions, nuclei stripped of electrons, it creates a quark-gluon plasma, a state of matter that existed in the first microseconds when the universe was too hot for protons and neutrons to form. For brief instants, scientists recreate the conditions of the newborn cosmos. They study supersymmetry, a theoretical framework that predicts partner particles for every known particle. No supersymmetric particles have been found yet, but the search continues. If they exist, they could explain dark matter and resolve mathematical inconsistencies in the standard model. They study extra dimensions. Some theories suggest that the universe has more than the 3 spatial dimensions we experience. These extra dimensions might be curled up so small that we cannot perceive them directly, but at very high energies, their effects might become visible. The LHC looks for these signatures. The research is fundamental. It addresses questions that have puzzled humanity for millennia. What is the universe made of? How did it begin? What forces govern its behavior? These are not practical questions in the immediate sense. No one is going to build a better smartphone because of the Higgs boson, but they are profoundly important questions about the nature of reality itself. And the practical benefits do come eventually, often in unexpected ways. CERN invented the World Wide Web in 1989. Tim Berners-Lee, a British scientist working at CERN, needed a way to share information between researchers using different computer systems. His solution was a network of linked documents accessible through a simple interface. The web was not built to transform global commerce and communication. It was built to help physicists share data, but transform the world it did. Medical imaging benefits from CERN technology. The detectors used to track particles have been adapted for positron emission tomography, PET scans that help diagnose cancer and monitor brain activity. Hadron therapy, a cancer treatment that uses proton beams to target tumors with minimal damage to surrounding tissue, grew directly from accelerator physics. Grid computing, the distributed processing of massive datasets across networks of computers, was pioneered at CERN to handle LHC data. This technology now underpins everything from climate modeling to genomics research to artificial intelligence training. The pattern is consistent throughout history. Fundamental research driven by curiosity rather than application generates technologies that transform society decades later. James Clerk Maxwell's equations describing electromagnetism in the 1860s seemed purely theoretical. They gave us radio, television, radar, and every wireless technology we use today. Einstein's relativity, a theory about the nature of space and time, enabled GPS navigation and modern cosmology. CERN continues this tradition. The discoveries being made today, the particles being found, the forces being understood, will shape technologies we cannot yet imagine. But let us return to the fears. Are they entirely baseless? Is there any legitimate concern about the research at CERN? The honest answer is that science always involves uncertainty. The LHC explores uncharted territory. When you push into the unknown, you cannot know in advance what you will find. This is the nature of research. The safety assessments CERN conducts are thorough and rigorous, but they are based on current understanding. Current understanding could, in principle, be wrong. This is not a reason for panic. It is a reason for humility. Scientists at CERN acknowledge that they are exploring new physics. They acknowledge that surprises are possible. They argue convincingly that the evidence overwhelmingly supports the safety of their work. Cosmic rays have been conducting similar experiments for billions of years. The universe has not collapsed, but they do not claim absolute certainty. No honest scientist ever claims absolute certainty. What they claim is that the probability of danger is so small as to be effectively zero, that the benefits of understanding the universe far outweigh the infinitesimal risks, that stopping the research would be a far greater loss than any conceivable harm from continuing it. The conspiracy theories take the uncertainty and amplify it. They ignore the evidence and focus on the unknown. They mistake the admission that science is incomplete for the admission that danger is imminent.
They confuse the openness of scientific inquiry with the secretiveness of hidden agendas. This is a fundamental misunderstanding. Science is open precisely because scientists do not claim to have all the answers. The tentativeness of scientific conclusions is a feature, not a bug. It is what allows science to correct itself, to improve, to get closer to truth over time. What the conspiracy theories reveal is not a flaw in CERN's research, but a flaw in our cultural relationship with knowledge. We have become accustomed to certainty. We expect clear answers. When science cannot provide them, we fill the gap with stories. Stories of portals and timelines and secret rituals. Stories that offer the certainty that science cannot. The question is whether we can learn to live with uncertainty, whether we can accept that some questions do not have definitive answers, whether we can trust the process of inquiry even when the conclusions are provisional. This is not easy. Humans evolved to fear the unknown, but it is necessary if we are to continue pushing the boundaries of what we understand. CERN will continue. The LHC will run until at least the 2040s. Upgrades will increase its power. New experiments will probe deeper into the fabric of reality, and new conspiracy theories will undoubtedly emerge. The scientists who work there hope that their discoveries will illuminate the universe. They hope that understanding will triumph over fear. They hope that the machine beneath the mountains will remain what it was always meant to be, a tool for exploration, a monument to human curiosity, a testament to what we can achieve when nations set aside their differences and work together toward knowledge. Is CERN shifting us into a parallel universe? No, the physics does not support it. The evidence does not support it. The cosmic ray argument alone is sufficient to dismiss the claim. Will CERN destroy life on Earth? No. The same arguments apply. The universe has been running this experiment for billions of years. We are still here. Are there things we do not yet understand? Yes, always. That is the nature of knowledge. The horizon of the unknown recedes as we advance, but it never disappears. Is it dangerous to explore the unknown? Perhaps, but it is far more dangerous not to. The alternative to knowledge is ignorance. The alternative to inquiry is stagnation. The alternative to pushing boundaries is accepting limits that may not be real. CERN represents the best of human ambition, the determination to understand, the willingness to invest, the capacity to collaborate across borders and cultures, the courage to ask the deepest questions and pursue the answers wherever they lead. The conspiracy theories represent something else, the fear of what we cannot control, the distrust of institutions, the longing for simple explanations in a complex world. These are understandable impulses, they're human impulses, but they are not guides to truth. In the end, the choice is ours. We can embrace the search for knowledge with all its uncertainty and humility, or we can retreat into stories that offer comfort but not truth. CERN has made its choice. Every day in the tunnel beneath the mountains, protons race at nearly the speed of light, colliding and creating, adding one more piece to the puzzle of existence. The machine runs on, the questions remain, and the journey toward understanding continues. If you enjoy deep investigations into the mysteries of science and the fears that surround them, please like this video and subscribe to the channel. Your support makes these detailed stories possible. Tell me in the comments, do you believe the conspiracy theories about CERN, or do you trust the science? And which mystery should we investigate next? The secrets of Area 51? The truth behind the Philadelphia experiment? The science of quantum consciousness? Every mystery has its believers. Every fear has its roots, and every question deserves a thorough investigation. Thank you for watching. I will see you in the next investigation.